Okay, so in this video, what we're going to do is I'm just going to talk about Bernoulli trials, or the binomial distribution here. We have four conditions here for Bernoulli trial. We must have a finite number of trials, so it must be a definite number of trials that we're talking about, in this case n. There can only be two possible outcomes, success or failure. The trials must be independent of each other. In other words, one trial cannot affect the outcome of the following trial, and so on. The probability of success in each trial must be the same. This is P. So P here is going to be the probability of success, and Q is going to be the probability of failure. Because there are only two possible outcomes here, success or failure, if we add P and Q, we must get 1. Okay, so any experiment then, or any trial, any experiment that satisfies these four conditions here is called a Bernoulli trial. Okay, so we're going to look at, first of all, I'm just going to write down a formula that we're going to use in this particular question, or in this particular video. So we're going to look at the probability of or number of successes. Or probability of or successes. That's going to be n, choose or. N is the number of trials, and or is the number of successes here, and it's going to be P multiplied by P here, which is the probability of success, and that's going to be to the power of or. We're going to have Q here, which is the probability of failure, and that's just going to be to the power of n minus or. So this is our formula that we're going to use in Bernoulli trials. Okay, so what I'm going to do is I'm going to look at a particular example of a Bernoulli trial, and we're going to use this equation here to work out the probability of or successes and so on. Okay, so I'm going to talk about a match, a football match, where John, for example, takes a number of penalty shots. So the shots are independent of each other, and his probability of scoring with each shot is 4/5. So we're going to take the probability that he scores is going to be 4/5. Okay, so the probability then, obviously, that he misses is going to be 1/5. Okay, so the probability he scores is 4/5. Probability that he misses the penalty shot is going to be 1/5. Okay, so the first question we're going to ask is find the probability. So the first question is find the probability that John, he misses. Find the probability that he misses each of his first 4 shots. So he misses each of his first 4 penalty shots. We want to find this probability here. Okay, so how are we going to go about doing this? Well, I'm going to look at 2 different methods. One where we use this particular formula, and one where we don't use that formula. So let's look at the first one, where let's say we're not going to use this formula here. We're going to use standard method. So the probability that he misses each of his first 4 shots. Well, the probability that he misses his first shot is going to be 1/5, and he misses the second one, and he misses the third one, and he misses the fourth one. So this is the probability that he misses his first 4 penalty shots, which is 1/625. So that's our first method. Just write down the probabilities, multiply them. It's the first shot and the second and the third and the fourth, so you just multiply them here. Okay, so now let's use this formula here to work out the same probability. Right, so what we want here is, well, let's just write down these values here first of all. Well, we have P here is probability is of success. P is the probability of success. Now, you've just got to be a little bit careful here. The probability of success in this particular case is that he misses. We are looking for the probability that he misses each of his first 4 shots. So we want him to miss. So that's going to be P. The probability that he misses is going to be P, and that is 1/5. The probability then that he scores in this particular case is going to be Q, because we don't want him to score. We want the probability that he misses each of his first 4 shots. So Q is actually a failure in this case, and that's going to be 4/5. We know that he takes 4 penalty shots, so n is just going to be equal to 4. Okay, n equal to 4 there. Right, so our formula then, we want the probability of our successes, the probability of that he misses 4 is going to be, well, n is 4. Okay, he takes 4 shots. We want him to miss 4 times. So we want him to miss 4 times. Probability of success that he does miss is 1/5. So a 1/5 here to the power of r, which is 4. And Q here is going to be 4/5. He fails 4/5. The probability that he fails, in other words, he scores in this particular case. And that's going to be 4 minus 4, which is 0 here. Okay, so 4 choose 4 here is going to be 1. 1/5 to the power of 4 is just going to be 1/625. And 4/5 to the power of 0, anything to the power of 0 is just 1. So our answer here is the same as above here. It's just going to be 625. So we got the same probability here. Okay, so that's our first question. The probability that he misses each of his first 4 shots. Okay, so let's move on to doing something else. Let's see. We'll do number 2 here. Let's see, we'll have a look at the probability that he, we'll take that he scores exactly 3 of his first 4 shots. So in this case, we want him to score exactly 3 of his first 4 shots. Exactly 3 of his first 4 shots. So this time we want him to score. We want him to score. In the first question, we wanted him to miss. So missing was a success. In this case, we want the probability that he scores exactly 3. So success in this case is going to be that he actually scores. So let's have a look at what we need to do here. Okay, so in this case, again, n is equal to 4. There's a finite number of trials. N is equal to 4. Or in this case is the number of successes. So we want the probability of r successes. So he scores exactly 3 times. So r is going to be 3. The probability of success in this case is p, which is 4/5. And of course, q then is going to be 1/5. This time we want him to score, remember. So the probability that he scores exactly 3 of his first 4 shots is going to be 4 choose 3. Now we're going to have 4/5, and that's going to be to the power of r here, which is 3, and then 1/5 here to the power of n minus r, which is 4 minus 3, which is 1. So if we calculate this, 4 choose 3 here is the same as 4 choose 1 by the twin rule, which is just 4. 4/5 to the power of 3, that's 4 to the power of 3, 5 to the power of 3. So 4 to the power of 3 is 64, 5 to the power of 3 is 125, and then 1/5 to the power of 1 is just 1/5. So we've got 3 fractions multiplied here, multiply all the tops, multiply all the bottoms, and you get 256 all over 625. So this is the probability that John scores exactly 3 of his first 4 shots. Okay, that's the second question then. So let's have a look at another one. Okay, so in this particular question, we're going to ask the question. We're going to look at John. In this case, he's going to take 10 penalty shots. He's going to take 10 penalty shots. So John is going to take 10 penalty shots. Okay. So what we need to do is find the probability that he scores at least 8 of them. So find the probability that he scores at least 8 of them. Okay, so he's taken 10 penalty shots. He must score at least 8 of these penalty shots. Okay, so let's have a look at that. Now, let's have a look first of all at n. N in this case is not going to be 4 anymore. He's taken 10 penalty shots, so n is going to be 10. Okay, and we want the probability that he scores at least 8. So really what we're looking for here is the probability that he scores 8, or the probability that he scores 9, or the probability that he scores, here in this case we're going to look at the probability that he scores 10. So these are our possibilities here, our only possibilities really. We want the probability that he scores at least 8 of them. So we're looking at the probability that he scores 8, 9 or 10. Okay, so let's write each one of these out in turn. We know that n is 10. Okay, so we're just going to look at this one here first. So what we want here is, we know that n is 10 and we want him to score 8. So or successes, remember. So it's 10 choose 8. Or successes. In this case, success is scoring. So scoring in this case, the probability was 4/5. And that's going to be to the power of 8. And then missing or failing in this particular case is going to be 1/5. And that's going to be to the power of 10 minus 8, which is 2. So that's this one here, probability that he scores 8. Or then is just and, or plus, sorry I should say, or is plus. The probability that he scores 9, it's the same thing again here. So we're going to do 10 choose 9. Remember, we want 9 successes this time, so or is 9. So we have 4/5 here, and in this case 9 is going to be the power of 9, 1/5 here, and that's going to be 10 minus 9, which is 1. Or in this case is going to be, again, or is plus. So we're going to look at, in this case, he needs to score 10, so it's going to be 10 choose 10, and then we've got 4/5 here, isn't it? 4/5, yep, and then it's going to be to the power of 10, and then 1/5 here. 10 minus 10 is 0 here. So if we add these three up, this will give us the probability that John scores at least 8 of his penalty shots. Okay, so let's just work all of this out. Now we're going to end up with some fairly big numbers here, but you know, it's not too difficult after here. You do 10 choose 8. You've got to do 4 over 5 to the power of 8, so it's 4 to the power of 8 on top, 5 to the power of 8 on the bottom, 1 to the power of 2 and 5 to the power of 2. Then you multiply all the numerators, multiply all the denominators, and you get the following numbers. Okay, you can take my word for it. I'm not going to go through the calculations. You should be able to do those calculations at this stage. So you get some fairly big numbers. So you're going to get 2, 9, 4, 9, 1, 2, 0 on top, and you get 9, 7, 6, 5, 6, 2, 5 on the bottom here. When you work this one out, you get 2, 6, 2, 1, 4, 4, 0 on top, and you get 9, 7, 6, 5, 6, 2, 5 again on the bottom here, same as over here. And it's going to be something similar here. You do exactly the same. So you over here you get 1, 0, 4, 8, 5, 7, 6 on top, and on the bottom you get 9, 7, 6, 5, 6, 2, 5 again. So 3 fractions, very big fractions here, but you end up with 6, 6, 1, 9, 1, 3, 6, all over 9, 7, 6, 5, 6, 2, 5. So this is your probability here that John scores exactly, or sorry, he scores at least at least 8 out of his 10 penalty shots. Okay, so he takes 10 penalty shots. What's the probability that he scores at least 8 of them? It's this thing here, and you can work that out as a decimal as well. I'll leave that to you to do.